All right. Good morning, everybody. Welcome back. So let's finish what we started on Monday. Okay, so let me share my screen with you. Okay, so we are starting a very important part of the course, and it will require a little bit more of extra work from your side. Okay. So the last thing I showed you was the octet rule. Any element in the periodic table will try to imitate the noble gas configuration because that is a stable electron configuration, okay? So remember that stability, chemical stability means 8 electrons in the valence shell. And the valence shell is the very last electronic shell that you have for an element. Okay, so we will lose or gain electrons in order to achieve stability. Then the last thing we did was to quickly determine the most likely charge for the following elements. So let me go to the other screen now. So that is what we did. So I showed you in details for potassium. And then for the other elements, I showed you how to use the trick of looking at the group number that the element belongs, and then figuring out if electrons need to be added or lost. Every time you lose electron, the charge becomes positive, and every time you gain electron, the charge becomes negative. Remember that the charge is always related to the number of electrons, okay? Those are the ones that you are losing or gaining. No changes in the nucleus. And therefore, chemistry is basically a science that deals with valence electrons. Those are the ones that will react. And of course, if an electron is lost, someone has to gain that, and vice versa. So now what I want to show you today is how elements are bonded to form compounds. And that's our goal for today. Just a second. All right. Sorry about the back and forth between screens here. Okay. The elements will combine in order to reach the stable noble gas configuration. Different compounds are grouped in classes as a function of their bonding. We will start with two major classes. Okay. We will talk about ionic compounds and covalent compounds. Covalent compounds are also called molecular compounds. Oops, sorry. Let's go back here. Okay, so let's start with the ionic compounds. I'm going to call the kind of bond formed in this sort of compound as ionic bonding. So I want to go first over the characteristics of an ionic bonding with you. First one involves an element that needs to lose electrons, okay? Therefore, this element will receive the name of cation, and the charge is going to be positive, and an element that needs to gain electrons. The element that gains electrons will receive the name anion, and therefore it will have a minus charge. Okay, so the ionic bonding is the perfect marriage. Involves an element that wants to lose electrons and an element that needs to gain electrons. Who are the elements involved in an ionic bonding? Usually is formed between elements from groups 1, 2, or 13, okay? And those will be the cations. Combined two elements from groups 15, 16, or 17. And those are going to be the anions. And attention to that, hydrogen is not an element from the group 1, okay? Hydrogen is at the top of the group 1, but doesn't belong to that group. All right, and again here, losing electrons to complete the octet means positive charge. Once you have an element with positive charge, you will label this element as cation. And gaining electrons to complete the octet means negative charge. And therefore, every time you have a negative charge, this element now is labeled anion. Okay, so I have a question here. Dennis, why does hydrogen not belong to group 1? Okay, so this is a good question, and it's still a matter of debate. Hydrogen shows some properties that are similar to group 1, but other properties that are similar to the group 17. Okay, so because of that, we cannot label hydrogen in either of those two groups because it has this ambiguous behavior. So that's why it does not belong to the group 1. It's there because the atomic number is 1. That's the only reason. And in some tables, you will see hydrogen in two positions, either at the top of the group 1 and also at the top of the group 17. And that's the reason, okay? All right. Okay, guys, very good, very good. Let me give you some more time to take notes, and then we will move on to the next slide.
Excuse me, Professor, I got a little bit more clarifying question on that.
Yes.
So hydrogen has properties of both, is it more physical characteristics or is it more chemical characteristics?
More chemical.
Okay, thank you.
Yes, okay, no problem. Right. Okay, so let's move on. All right, awesome. So now we want to do with you an example showing the combination between sodium and chlorine to form an ionic compound, okay? So remember that sodium belongs to the group number 1. Therefore, here you can see 1 valence electron, and chlorine belongs to the group 17. Every time you are between the groups 13 and 18, you will subtract 10 to get the number of valence electrons. And as you can see here, chlorine has 7 electrons. So you must be able to locate an element in the periodic table and determine right away the number of valence electrons. Okay, you need to do that. Okay, let's switch to the other screen really quick. Okay, awesome. So sodium by itself is not stable because it does not have 8 electrons in the valence shell. Therefore, it will either lose electrons or gain electrons to achieve stability. 1 electron in the valence shell is easier to lose this electron. So the element loses 1 electron. The fact that sodium lost 1 electron, now it became sodium plus. Okay? Every time you have an element with a positive charge, this element is going to be labeled cation. On the other hand, chlorine has 7 electrons in the valence shell. To achieve stability, it has to gain 1 electron. When chlorine gains 1 electron, it becomes Cl minus. And every time you have an element with a negative charge, this element receives the name of an ion. Okay, so we have the 2 pieces of the puzzle. 1 element that needs to lose electrons and another element that needs to gain electrons. So that's the perfect marriage. Therefore, sodium is going to combine with chlorine. So let's write like that. And form Na. I'm going to put the charge here, then we can remember. Cl minus. Okay, so you don't need to write the charges all the time. You can simply write NaCl. Each sodium needs to lose 1 electron and each chlorine needs to gain 1 electrons. Therefore, they will combine and form thus a stable compound. The formula of this compound is NaCl. Okay, so C here, because why I need an element from group 1, 2, or 13 combined with an element from groups 15, 16, or 17. I always need a part that loses electron and another part that gains electrons. Okay, ionic bonding is a combination of the opposites. Okay, very good. So now that you understand why I need to combine these two kinds of elements, so let's talk a little bit how we determine the formula of the compound that's going to be formed. So I will start with an example here, and let's start with the case of the compound formed between strontium and iodine. Okay. So let's start with that. So let's use colors here. So let's first take a look at strontium. First thing is to locate strontium in the periodic table. And strontium is right here. Okay. And look at the number of the group. So strontium belongs to the group 2. That means this element has 2 valence electrons. Of course, 2 valence electrons is not a stable electron configuration, and we have to decide, is easier for strontium to lose or gain electrons to become stable? There's always 2 options. One of them is going to be the easiest one, the other one, the hardest one. Nature will always take the easiest way to achieve stability. The easiest way for strontium to achieve stability is just to lose 2 electrons, and it becomes strontium 2 plus. Just the fact that strontium lost 2 electrons, we can call now strontium 2 plus as the cation. Okay. Cation is always the positive part. Now let's take a look at iodine. Iodine is right here, belongs to the group 17. Seventeen minus 10, that gives us 7 valence electrons. 7 valence electrons is not stable, but it's really close to the stability. Iodine, therefore, needs to gain 1 electron to achieve 8, and therefore it's going to get a 1 minus charge. And every time that we have an element with a negative charge, we will label this element as the anion part of the compound. Okay, so we have here strontium that needs to lose 2 electrons to become stable, and iodine that needs to gain 1 electron to become stable. So that's the perfect marriage, and they will combine with each other to form a stable compound. However, pay attention to one detail here. Each strontium needs to lose 2 electrons. However, each iodine has the capability of gaining just one electron. Therefore, strontium is not happy when bonding to only one iodine. It needs to have two iodines to satisfy this compound, okay? So therefore, the way we are going to represent that one strontium is bonded to two iodines is by adding the number of iodines in the bottom right corner. Okay, so this formula here means that one strontium is bonded to two iodine. Okay, 1 to 2. Okay, so I like to use a very simple trick to write the formula of any ionic compound. Let me show you how you quickly determine the formula of an ionic compound. So first thing, write each element and the charges side by side. And then what you are going to do is to cross the number of each charge. How does that work? The number of the charge for strontium is 2. Just ignore the sign. So the number 2 is going to be moved to the bottom right corner after the iodine. And you are going to do the same thing with the charge for the anion, the negative element. Just move the number, okay? So this number 1 is going to be moved right next to the strontium. What you will get is strontium 1, iodine 2. Every time you have the number 1 as your index, you don't need to write it. So that becomes SRI2, okay? And that is the trick. If you understand why we need 2 iodines for each one strontium, then the trick will make things easier, okay? Put the elements side by side with the charge and then simply cross the charges.
I have a quick question.
Yes.
So like, let's say you had strontium pairing with sulfur. So it has a, it's an anion with a -2 charge. Using that rule, you'd have like SR2, S2, but wouldn't you just call that 2 strontium sulfur? Like it's just 2 of those things bonded together. You wouldn't write 2 and 2.
Exactly. So every time you have 2 and 2 or for example, 3 and 3, you can
Reduce.
simplify. Yes,
Yeah.
you can divide everything by the common factor. Okay, no problem with that. So if you think about each strontium will need to lose 2 electrons and each sulfur is capable of gaining 2, that means you just need 1 to 1. Okay, very good question. Thank you very much. So strontium plus sulfur, that will create SRS. Okay, so you can simplify here and it's all good. Okay, so I showed you when we are going to have an ionic bonding. What are the elements involved in this kind of bonding, and how to determine the formula of an ionic compound. Everything starts with locating the element in the periodic table, correctly determining the number of valence electrons, and then you combine both elements. Careful with the stoichiometry of the compound. You will determine that by crossing the charges, okay? And that's how an ionic bond is formed. Now that we know how to determine the formula, the next step is to determine the name of the compound formed. Nomenclature is something that requires a lot of practice. Unfortunately, we don't have time to practice a lot during the lectures, so I'm counting on you to go over the material when needed. Okay, so the rules here are very simple. The cation keeps the name of the parent element. Remember that cation is the positive element, okay? And the anion changes its name. It will be the name of its parent element, except that the ending is changed to IDE. Remember here that anion is the negative element in the compound. And the name of the ionic compound, which is also called salt, will be the name of the cation and the name of the anion. Okay, so let's see here 2 examples, compounds that we already determined the formula. First one is NaCl. Okay, so you need to know that the sodium is 1 plus and the chlorine is 1 minus. Therefore, this guy here is the anion and the other one is the cation. You will always write positive followed by the negative. Okay, so you always write first the positive and then followed by negative. And Brandon, yes, all ionic compounds are called salts. Okay, how do we name this compound? Let's start with the cation. The cation is very simple. It's just the name of the element. So we have here sodium. For the name of the anion, we are going to use the name of the element, except that the ending is changed to IDE. So here we have chlorine. When chlorine is combined with sodium, that will receive the name of chloride. Okay, change the end to IDE. Therefore, the name of the compound is sodium space chloride. Okay, let's look the next one. SRI2. So we have here strontium combined with iodine. There is a number 2 here because the charge of strontium is 2 plus. And there is a number 1 here that we never show because the charge of iodine is 1 minus. Therefore, we have here strontium 2 plus as our cation and iodine minus as our anion. Okay, so let's name this compound. First always is the name of the cation, and for that is simply the name of the element, strontium. Then we are going to give a space and write the name of the anion. The name of the anion is going to be the name of the element, except that the ending is changed to IDE. So we have here iodine. Let's take it out the end and replace by IDE. Therefore, it's going to be strontium iodide. And that is how you name ionic compounds. Okay, so you must be able from the formula to write the name and also do the opposite. Looking at the name, you must be able to write the formula. Just because I did not show an example, using the name to determine the formula doesn't mean I cannot ask you that, okay? Okay, so I want you to understand the concept and why we do things. And then from there, you must be able to understand what you are doing. And if you do that, you are going to be capable of solving any problem, okay? Never panic. When you panic, you do stupid things, okay? Just look, think, have a plan, and execute the plan. Okay, that's very good.
So for the second one, because there's two iodine atoms in the molecule, wouldn't it be strontium diiodide? Or
Okay, so very good question. When you have ionic compounds, you do not need to put the prefix to determine the amount of atoms, okay? Because strontium iodide, you need to know that strontium is 2 plus and iodide is 1 minus. Therefore, the only possibility is to have one strontium to 2 iodines.
okay.
Okay, okay. So that's a very good question. For ionic compounds, never ever write a prefix to identify the number of atoms. We are going to use that for the other class of compounds, the covalent compounds. And those are the cases we are going to use the prefix. Okay, I'm not going to lie to you. This part is a lot of work and we will need to work really hard to grasp it, okay? All right, so let's go back to the other screen. Okay, so we don't have time to cover everything today here, and I'm going to stop soon. The next class of compounds that I would like to show you are the covalent compounds, which are also called molecular compounds. For the covalent compounds, you are going to combine two or more elements that need to gain electrons. Okay, so now for the covalent bonds, we will combine elements that need to gain electrons to achieve the noble gas configuration. And this kind of bonding is based on the concept of sharing electrons. So if everybody needs to gain electrons, let's share them in order to make everybody happy. The elements involved in the covalent bonding are usually elements from the groups 13, 14, 15, 16, 17, 18, or hydrogen. Okay, attention here. Hydrogen will form covalent bonds. We will discuss in more details about covalent bonds in the second part of the course. What I want to show you right now is just how to name the covalent compounds. And we will discuss deeply the sharing of electrons in the second part of the course. All right, so I showed you in details ionic compounds, how we write the formula, how we name the compounds. And ionic compounds are also called salts, okay? We can also have oxides and bases as ionic compounds. Ionic compound is the perfect marriage. One element needs to lose electrons and another element needs to gain electrons. On the other hand, covalent bond requires a little bit more of accommodation. And we are going to combine compounds that will share electrons in order to achieve stability. Covalent compounds are also oxides, acids, or molecular compounds. So ionic compounds is the perfect marriage, and covalent compounds is more of a realistic marriage, okay? So you cannot gain all the time. You have to lose a little bit sometimes, and elements are going to share electrons in order to achieve stability. Okay, so I think this is a good point here for us to stop. It was a lot of information and I don't want to add anything else here. Remember that on Friday we will have in-class assignment. I will be here on Zoom if you have any questions. You don't need to sign in if you don't want to. And in any assignment in this course, you are free to discuss with your colleagues, and you should do that. This way, everybody can learn. One thing in the assignments, I don't need you to write the questions again, just give me the answers, okay? I already know the questions. You don't need to write me again. And this way you will not lose too much time as well. Let's just be efficient. And one important thing here, if you have any problems related to due dates or anything like that, just talk with me and we can figure things out, okay? So there is always flexibility. All right, with that being said, let's finish today at this point and we will pick up next week. Hope you guys have a good day. I will see you on Friday.
Thank you. You too.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you. Thanks, Professor.
Bye-bye.
Later, Professor. See you on Friday.